To understand how pathology can be caused by atrial fibrillation and any other arrhythmia, we must understand the basics of normal conduction of impulses through the heart. So we're going to start again with our simple illustration of the heart. Again, we're going to draw it the same way every single time. We're going to include our atria and our ventricles. For conduction, we're going to have to include two additional parts to our heart, and that's going to be our sinoatrial node up here. So sinoatrial, also referred to as the SA node, and down here our atrioventricular node, also known as our AV node. Okay. In normal conduction, the SA node is going to generate an impulse that will hit both atria, both walls of the atria, but also hit the atrioventricular node. From there, the impulse will move through the heart, through the atrioventricular node, down the conduction pathway through the heart, where it gets to the muscles of the ventricles to stimulate contraction. In normal conduction, this is all a coordinated relay of impulses and contractions that moves through the heart in waves. This allows the atria to contract and empty that blood in its chambers into the ventricles before the ventricles then get the impulse to contract and then pump that blood into systemic circulation. Now we'll see how that differs in atrial fibrillation. So I'm going to draw a heart right next to it so we can compare. Again, we're going to draw it exactly the same. Include our atria, our ventricles. We're going to include our SA node and our atrioventricular node. Okay. The difference is that now in AFib, when our sinoatrial node generates an impulse, it is very erratic. Instead of hitting both atria simultaneously and hitting the atrioventricular node, the signal basically ricochets through the heart. So it's going in circles all around, it's just hidden everywhere. It goes through the atrioventricular node, and it does not follow the conduction pathway as coordinated as it does in normal cardiac conduction. So what we see in AFib is that the atria may not be done contracting when the ventricles already will receive the impulse to contract. And so this means that the atria cannot fully empty its chambers, which results in pools of stagnant blood. And wherever blood is stagnant, it is likely to clot. In addition, most patients are not going to be in AFib the entire time. They will convert in and out of normal sinus rhythm and AFib. And so you have a conversion between the weak and uncoordinated contractions of AFib and then those strong coordinated contractions with normal sinus rhythm. And this is what creates the opportunity for clots to become dislodged from the atria and enter systemic circulation, where they can block off blood flow to critical sites like the brain and the lungs.